Okay, so in conclusion, so workflows help scientists orchestrate these complex, multi-stage computations, allows them to automatically parallelize these across distributed infrastructures and automatically manage data. And clouds have many benefits and drawbacks for workflows, from provenance tracking, sharing workflows, controlling the environment, and other things that clouds really provide a lot of great features for workflow applications. Deploying, the main challenge here is deploying workflows in the cloud, which is problematic because you have to set up these complex distributed environments, and it requires a lot of administration. It's really, I think, beyond the ability of the average science user to go out and deploy this without some tools. And there are some tools that exist, but it's still difficult. I think the performance of workflows in the cloud is manageable. Unlike these tightly coupled MPI codes and HPC applications, workflows aren't as impacted by poor network performance and high network latency. So it makes them a lot easier, a lot more reasonable to deploy in the cloud. But there are a lot of also cost performance trade-offs you have to consider if you're going, say, to a commercial cloud. And like I said, I think science clouds maybe are a better solution for this. And like I just said in the previous case study, clouds are not necessarily cheaper or easier than alternatives such as the TeraGrid or Exceed. And also more work needs to be done on tools for automatically deploying applications. For platform as a service, I think that would be a way to get around this issue of the complications of administering a workflow system. If there was a platform as a service workflow management system that users could just submit their workflow to, and then it would automatically take care of all of the resource management issues, that would be great. And also dynamic provisioning, which is an interesting research question at this point. So with that, I want to say, finally, we have a Pegasus tutorial up if you want to, if you're interested in looking at workflows. It's virtual machine based, and you can either get it on VirtualBox, download the virtual machine image from our website, or there's virtual machines deployed on Amazon EC2, and also FutureGrid. This coming soon is, you can scratch that out. Actually, if you go to the FutureGrid portal, there's a link under tutorials to the Pegasus FutureGrid tutorial, and it will show you how to run individual VMs with Pegasus, and also clusters, virtual clusters with Pegasus on FutureGrid. Don't use the Eucalyptus. We found out that the Eucalyptus one is broken. Use the Nimbus one instead. But here's the website for the tutorials if you're interested. And here's our collaborators and the other people on the Pegasus team. And if you're interested in Pegasus, you can always go to the Pegasus website here, pegasus.isi.edu. And I will take any questions, I think, if there are some.
Questions? Yes.
How many nodes are there in workflow graph? That means how many tasks are there?
So the question was, how many tasks are there in a workflow graph?
Well, so is there a specific workflow that we're asking about, or? I mean, it depends on the application entirely, the number of tasks that are in it. Maybe I misunderstood the question.
No, average, I mean, what is the upper bound of the size of the graph? So just to get a concept.
Oh, so what is the upper bound? So right now we're running workflows that have on the order of millions of tasks. That galactic plane workflow that I showed earlier, each one of those workflows has, I think, 10 million tasks. But there are tricks. So the Pegasus is a DAG-based, uses a DAG-based workflow representation, which means you have to list out all those tasks. But there's ways to create hierarchical workflows so that you can split it up into smaller pieces to make it more manageable.
given a graph of size like million nodes, you have to embed that graph over a virtual cluster. So do you have any result to that reaction? Embed that million node graph to a virtual cluster, which has to be created honoring the underlying physical system.
Sorry, I'm having a hard time hearing the question.
So the question is, isn't it tough to take 1 million tasks and put them on a virtual cluster? At least I think that was the question.
Yes, and in fact, the galactic plane example is not one that we deployed in the cloud. The examples that I showed earlier, those workflows are on the order of like 50,000 tasks. They're not 10 million task workflows. That workflow is really huge. I think it's 18 million CPU hours, which would be an enormous Amazon bill.
Yes.
I do understand about the Periodogram. So you have run 1, run 2, and run 3. These 3 run is the same input data and same program.
So these are, it's the same input files, different parameters. So they're different science parameters.
Okay,
So one is, the one on the end just happens the way that they wanted to analyze the data. It required a lot more computation.
so you will generate because the output will be different because the output is so different for the parent. Like it's 3,000 gig, which compared with others.
Yeah, it's a different, the outputs are different. The workflows are different. I mean, the input data is the same, but the output data and the analysis that's being done is different. The main point of this is to show that on the low end, it's easy to go to a commercial cloud and run sort of small scale science applications. But once you cross a certain threshold where you have to start budgeting for it, it may be easier just to go and use Exceed at that point, or a science cloud if one is available to you.
Any more questions?
The storage system performance graph, at least for the cluster file system and PVFS, do you know whether they have the same kind of network and hardware?
So yeah, all these use the same instance type on Amazon in the same data center. I can't guarantee that that they're the same VM or the same machines, because I don't have any control over the way Amazon places the VMs. But they were run at basically the same time, so probably similar.
Okay, let's give Gideon a final virtual applause.